Alright, let's learn what a conditional is. Did you know that the statement, if I was a 7-foot tall woman, then I could fly anywhere in the world, is actually true? So I want you to think about that for a second. I'm obviously not 7 feet tall, nor am I a woman. But if I were, then I could fly anywhere in the world. Now let's figure out why this statement is true, because I think most people would argue that this is false. Well, you'll notice that this statement has an if-then. So if-then, what actually occurs is we call this a conditional. You probably have heard this. If you clean your room, then you can go out. Now let's let A and B statements be the following. A, you clean your room, and B, you're allowed to go out. So how we would write this in a mathological sentence would be A, right arrow B. And reading that would be if A, then B. Well, now let's look at the truth table of this. So we have the following truths. You could have A is true, B is true, and so on. And now let's think about this. Before we go to the next and see what the truth table of the implications, I want you to think about which of these scenarios would make you upset or kind of cheated at your mother or father who said, if you clean your room, then you get to go out. And which statements would you be okay with if this happened? Okay, so the first line says, you've cleaned your room and your parents let you go out. I don't think you'd have a problem with that. In fact, I think that seems quite reasonable. The next line says, you cleaned your room, but your parents didn't let you go out. Now you might have a problem with that. That might seem a little unfair. The third line says, you didn't clean your room, but your parents still allowed you to go out. Once again, I don't think you're going to have a problem or an issue with that. And the last one is, you didn't clean your room, so your parents didn't let you go out. And of course that doesn't seem like you should have a problem with that either. Hence, why we get our truth tables is the following. Every one is true except for the second one, where you actually did what your parents requested and you didn't get the reward. So an implication is only false if the if statement is true and the then statement is false. Which brings me back to, since I'm not a 7-foot tall woman, that means the then part is irrelevant. As you can see in the last two rows, if the part A or the if part is false, then the implication will always run true. Now, there are equivalent statements. There are statements that your parents could say that mean exactly the same thing. So let's look at the first one. Imagine if your parents said, if you go out, then you can clean your room. Now, is that the equivalent statement? That would be, if B, then A. Now, you should think about this really quickly, that of course it is not equivalent. This is called the converse, and the converse is not the same. So if A, then B is not equivalent to if B, then A. Let's have about this one. If you didn't go out, then you didn't clean your room. So again, you'll notice the if and then are flipped, but they're also the negation of both. So we would write this as not B implies not A. So think about this. If you didn't go out, would that mean you didn't clean your room? And hopefully you can see that that is true. That we call this the contrapositive, and the contrapositive is equivalent. Now we use these statements is sometimes in programming or in other parts of logic that it might make sense to put the then part first. And you can see that just putting the then part first is not sufficient. We have to negate it, and we have to make it imply the negation of the if part. We also learn about biconditionals. Biconditionals are mostly used as definitions. There is lots of other applications, but you'll see a lot of biconditionals as simply definitions. Alright, as you most know, that a polygon with exactly 3 sides is what we call a triangle. So let's have two statements here. Statement A is that a polygon is a triangle, and statement B, the polygon has exactly 3 sides. You're going to notice that for one to be true, the other one must also be true. And what we call this is we actually say A implies B and B implies A. Or another way of saying it, which is probably more common, is we say A if and only if B. Now putting A and B statements back in, we would read this as, a polygon is a triangle if and only if it has exactly 3 sides. Now I want to talk about the difference here than the previous example. This one's different in that if I told you I have a polygon that has only 3 sides, then it automatically implicates that this polygon is a triangle. As well as if I told you I have a polygon with a triangle, you automatically know that this polygon has exactly 3 sides. So this one actually goes both ways. This truth table is actually done by proving that A implies B and B implies A. Now if you think about, remember how an AND works. An AND works means that both parts must be true. So a biconditional is only true if both parts have the same truth value. So looking at that statement above, imagine A and B, here are the various truth and false it could take on. Let's see how the truth table of the biconditional looks. In the first row, both A and B are true, which means in both parts of the AND, you have true implying true, which turns true. And if both parts of the AND are true, then the AND runs true. In the next 2 rows, you see one is true while the other is false. This means that one conditional will be true, namely the one that is false implies true. As we know, if the if part is false, then the conditional runs true. However, the other conditional is going to be true implies false, which is the one and only way that a conditional is false. Thus means that in the AND part, we're going to have one part is true and one part is false, which means the AND will run false. And lastly, you have A and B are both false, which means both if parts of each conditional are going to be false, which as we've seen earlier, if the if part is false, then the conditional runs true, which means we have true and true once again, and the biconditional is true.